So as you would with any lab, make sure you're following the safety procedure. So that means wearing your goggles at all times, pants, and a sleeved shirt. Now you can move to a procedure. Take a 50 milliliter beaker and weigh it. Make sure to tare the scale and have all the panels closed before measuring a weight. Now you will need to record this data because it will be essential in finding an accurate measurement of the water's mass later on. Next, you are ready to pipette the water. So first, collect the pipette in the pipette bulb, and then squeeze the bulb before placing it on the pipette and slowly lower the pipette into the beaker. Now slowly release your grasp on the bulb and prepare to place your thumb over the top so that no water can drain below the desirable volume. However, if you squeeze the bulb in the water or place the pipette against the bottom of the beaker, water can rise into the bulb, causing damage to the equipment. After pipetting a certain volume from a graduated cylinder, bring the pipette eye level and measure the bottom of the meniscus. So what exactly is a meniscus? Well, due to the adhesive forces of the water and glass, the water molecules that come in contact with the glass rise, leaving the more central molecules of water at a true volume. This is indicative of what you actually want to measure. Take a certain amount of water into the pipette and make sure to record the starting volume as you pipette a chosen amount into a beaker, then measure the difference in volume and make sure to record this data. Now, measure the mass of both the water and the beaker. Using density equals mass over volume, we take the mass of the beaker in water minus the mass of the beaker over the change in volume. This should give you the density of water. Take a 25 milliliter volumetric flask and pipette a small amount of the given 20% stock solution. Now you will need to add water to the 25 milliliter mark on the flask. This will create a diluted solution. Now you will find the concentration of this new solution. To do this, you will take the conservation of mass equation and instead replace the mass with the concentration of the solution. Now you will simply multiply the first concentration by the first volume and then divide this by the new volume, which should be 25 milliliters. And by doing this, you will find your concentration. Take a certain volume of the unknown and make sure to ID this unknown. Now you will follow the same procedure as challenge 1, and using the same equation, density equals mass over volume, you can find the density of this solution. Finally, make sure to clean up your lab space and make sure everything is wiped down and all your equipment is dry.